In Unit 5, Notes Part 6, we will be covering metallic character and periodic trend summary. The tendency of an element to lose electrons and form a positive ion, which is a cation, is called metallic character. As you move from left to right across a period, the metallic character is going to decrease. And as you move down a group, the metallic character will increase. The tendency of an element to accept electrons to form an anion is called nonmetallic character. As you move from left to right across a period, the nonmetallic character will increase. As you move down a group, the nonmetallic character will decrease. In group 14, or 4A, which is the carbon family, why does the metallic character seem to increase as you go down a group? So we're starting with carbon, which is a nonmetal. We have silicon and germanium, which are metalloids in the middle. And by the time we get to the bottom of this family, we have tin and lead, which are metals. Now, metallic character deals with whether or not the atoms are going to want to give up electrons. And we can think about this in terms of the amount of attraction that these nuclei are going to have for their electrons. As I go down this family, there's going to be an increased amount of electron shielding. So while all of these elements are going to have the same number of valence electrons, they all have 4 valence electrons, when I get down to the bottom, because of all the shells of electrons that are standing between the last 4 valence electrons and the positive nucleus, it's going to be easier to remove those electrons, which is a metallic trait. So by the time we get down to tin or lead, they're more likely to behave as metals. Whereas at the top of the family carbon, it doesn't really have any electron shielding. It has 2 inner core electrons, but that's it. So since there is a lower degree of electron shielding, it's more likely to want to maintain its identity as a nonmetal. It's going to want to gain 4 electrons as opposed to losing 4. So in summary, why does the metallic character seem to increase as you go down a group? There is an increase in the amount of electron shielding. So going down the group, there are more shells of electrons, which means more shielding. This slide right here has a summary of many of the trends that we have discussed within these videos. We can see that our atomic radius is going to increase as we go down a group. We also said it decreased towards the right, or another way of saying that is that it increases towards the left. So to summarize these two trends together, I can say that my largest elements are going to be towards the bottom left-hand corner, and my smallest elements are going to be towards the top right. Other trends that we discussed were ionization energy and electron affinity. So those both increase as you go towards the right and towards the top. So an element like helium would have the highest ionization energy, and an element like francium at the bottom left would have the lowest. We also have metallic character increasing towards the bottom left, and non-metallic character increasing towards the bottom right. Now, by knowing these different trends, you can compare the relative type of each of these trends for any 2 elements, and we'll show you an example of that. For this checkpoint question, we are going to be trying to determine which element has a larger or smaller version of one of these trends. So for our first one, we are going to be looking at atomic radius, and we want to know which one is larger out of 2 elements. Our first comparison is sodium and rubidium. So out of these 2 elements, we have sodium, which will be right here, and rubidium, which is further down the group. We know that radius increases down a group. Or I could say that the largest radius is towards the bottom left-hand corner. Because rubidium is closer to the bottom left-hand corner out of these 2 elements, that would have the larger radius. When I'm comparing carbon and oxygen, these are both within the same row. We know that the largest element is going to be the bottom left-hand corner and the smallest is the top right. So really this question becomes, which of these 2 atoms is closer to the bottom left? Well, that would be carbon, because carbon is further over to the left. They're both the same distance up and down because they're within the same row. But carbon is closer to the left side. For our second question, we are trying to figure out which ion has the smaller atomic radius. This is a little more complicated. Now, the way that you should approach this, if I have something like Rb plus 1, if it were to lose an electron, it would be similar in size to krypton. So let's say that Rb plus 1 would have that position. Whereas if I have something like sulfur minus 2, if it was to gain 2 electrons, it would be similar in size to argon. Out of these two elements, argon and krypton, argon would be a smaller element because it is closer to the top right-hand corner. Therefore, by extension, the element or ion that is similar to argon is also going to be smaller. So the answer for this one would be S minus 2. So S minus 2 is smaller because it is somewhat equivalent to a smaller noble gas. We know that argon is smaller than krypton. Our second combination is even more complicated because that little trick that I just explained wouldn't work. If I have Cs plus 1, Cs is right here, if it were to lose an electron, it would be similar in size to xenon. And if iodine were to gain 1 electron, it would also be similar in size to xenon. So we're comparing both to the same element. So in that case, what you need to do is consider the pull from the nucleus. So we have Cs plus 1 and we have I minus 1. So for this first combination, I have cesium, which is going to have 55 protons, so 55 positives. And since I lost 1 electron, I'm only going to have 54 negatives left. For iodine, I have 53 positives, and I have 54 negatives. Both of these have the same amount of pull from the shells of the electrons, the same pull going outwards. If I want to know which one is smaller, it is going to be the one that has the greatest pull from the nucleus, the one that is greatest or best able to pull those electrons towards the center. Well, that's going to be cesium because that has 55. So if I am comparing two ions, and they are both similar to the noble gas, the same noble gas, whichever one has more protons will be smaller, and whichever one has less protons will be bigger. All right, for the next one, we have a different trend. Now we're looking at electronegativity. The highest electronegativity is towards the top right. So between magnesium and strontium, we have magnesium here, strontium here. It's going to be magnesium because it's closer to the top. Between boron and fluorine, it's going to be fluorine because it's closer to the right. For the next one, which atom has the greatest metallic character? Well, the most metallic character is towards the bottom left-hand corner. So I want whichever of the two elements is closest to the bottom left. To start off with, we have nitrogen and we have antimony. Well, they're both in the same family. They're both the same distance left and right. Antimony is further to the bottom. So that is going to be the one with the most metallic character. All right, for the next one, we are trying to compare calcium and copper. They're both within the same row, so they're both in row 4. Calcium is further to the left side, so that is going to have greater metallic character compared to copper. That concludes Notes Video Part 6. When we come back for Part 7, we'll be looking at the families of the periodic table.